Hi guys, welcome back to our channel. Now in today's video we are going to solve for the value of x in the exponential equation given. So you have x raised to power 9 plus x raised to power 6 is equal to 36. So we want to solve for the value of x. Okay, now if you check these x raised to power 9 and x raised to power 6, we have a common base of x, so we can break it down in this form as x raised to power 3 multiplied by 3. Remember, when you say 3 times 3, it is going to give you back 9, plus x, if you say x raised to power 2 times 3, that is 2 times 3 is going to give you 6. But according to the rows of indices, a raised to power m multiplied by n is the same as saying a raised to power n multiplied by n. So we apply this row of indices in this in x raised to power 2 multiplied by 3. So we can express it as again as x cubed multiplied by 3 plus x cubed multiplied by 2 is equal to 36. So basically we just it's just the interchange of the powers according to the rule. And then the next phase we are going to say let x cubed be equal to m. Let x cubed be equal to m. So where there is x cubed, we substitute with m as follows. We'll have m cubed plus m squared. You can see here we're substituting in this equation. This is equal to 36. Okay, and now if you check this 36, you want to express 36 in a way that will have a shared, powers of 3 and 2. In this way, we'll have m cubed plus m squared. This is equal to, you can express 36 in the form of, 6 can also be obtained as 27 plus 9. If you say 27 plus 9, this one is going to give you 36. Okay, and then we take 27 and 9. Now we proceed as follows. You'll have m cubed plus m squared minus 27 minus 9. This is equal to 0. Okay, so now we write this 27 and 9 in form of the basis of 3, with the basis of 3 as follows. So we'll have m cubed plus m squared minus 3 cubed minus 3 squared. This is equal to 0. If you say 3 cubed, it's going to give you back 27, and 3 squared is going to give you 9. Okay, we have m cubed plus m squared minus 3 cubed minus 3 squared. So here we'll have m cubed minus 3 cubed plus m squared minus 3 squared. This is equal to 0. Okay, so if you check clearly, we have the first part and the second part. So the first part is the difference of cubes, because we have you can see this is it's m cubed and 3 cubed, m cubed minus 3 cubed. So this is the difference of cubes. Okay, difference of cubes. And here we have m squared minus 3 squared, which suffices to be the difference of 2 squares. And how do we solve for the difference of cubes? So for instance, if you have a cubed minus b cubed, this can be expressed as a minus b multiplied by a squared into brackets plus ab plus b squared. Okay, this is the approach. This is the approach that we normally use for the difference of cubes. So in our equation we have m cubed minus 3 cubed This one we're going to express it as m minus 3 into bracket m squared plus 3m plus 9 okay, plus 9. And then the second part of our equation we have m squared minus 3 squared, and this one is the difference of two squares. For instance, if you have a squared minus b squared, this one is expressed as a minus b multiplied by a plus b. So this is the difference of two squares. Now, if you go back to our equation that we have m squared minus 3 squared. This one is expressed as m minus 3 multiplied by m plus 3. Okay, so if you go back and we substitute m minus 3 multiplied by m squared plus 3m plus 9, we just input back to our equation. This one will give us m minus 3 into bracket we have m squared plus 3m plus 9. Remember, we have the second part of the difference of two squares, so we add m minus 3 multiplied by m plus 3. This is going to give us 0. Okay, since you have m minus 3 multiplied by m squared plus 3m plus 9 plus m minus 3 and then m plus 3, so we just, if you check, we have m minus 3 is the common value, so we factor out m minus 3. So we factor out m minus 3, so that we'll have m squared plus 3m plus 9 plus m plus 3, close the bracket, this is equal to 0. Okay, this is equal to 0. So as you can see, we have two parts, m minus 3 and into the bracket m squared plus 3m plus 9 plus m plus 3. So we'll have the first part as m minus 3, this is equal to 0. So that gives us the first real roots, that is the first real roots is equal to m is equal to 3. So that shows that one of the real roots or the real numbers in our equation is equal to 3. Okay, so the next part we have m squared. This is now the next part. We have m squared plus 3m plus 9 plus m plus 3, this is equal to 0. So this is expressed as m squared, so this is 3m plus m, this is 4m. Okay, this is 4m plus 9 plus 3 is equal to 12, so it's plus 12, this is equal to 0. So this now forms a quadratic equation. This is a quadratic equation. It's a quadratic equation. Now we have our m squared plus 4m plus 12, which is our quadratic equation. Okay, so in this quadratic equation we have a discriminant. Value, of course, that is less than 0. So therefore this discriminant is equal to b squared minus 4ac, which is less than 0. Okay, so if you check from our quadratic equation, this is given as 4 squared, that's our b squared, minus 4 times 1 times 12, this is less than 0. So this is equal to 16 minus 48, which is less than 0. So that means that minus that 2 is less than 0. So this means that we have two complex roots, or rather imaginary roots, and these imaginary roots are expressed in form of alpha, which is a plus ib, and beta, which is expressed as a minus ib. Okay, so to calculate for alpha and beta, we apply the quadratic formula. So our m from our equation is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So if we plug in the values, we are going to have minus 4 plus or minus the square root of course 4 squared minus 4 times 1 times 12. Okay, this is divided by 2, so this will give us minus 4 plus or minus, this is 16, 4 squared is 16, minus this is 48 over 2. So this will give us now minus 4 plus or minus the square root of minus 32 divided by 2. That's what we have. So this means now if you divide negative 4 by 2, this will give us minus 2 plus or minus. Now we are going to express this minus 32 in this format. We are going to have minus 1 multiplied by 16 times 2. Okay, times 2. This is divided by 2. So this is going to give us minus 2 plus or minus the square root of 2 multiplied by 2, then we multiply by I. Okay, so therefore alpha is given as minus 2 plus 2 square root of 2i, and beta is given as minus 2 minus 2 square root of 2i. Okay, these are our complex values, alpha and beta. And remember, in our real root, which is given as m is equal to 3, we assume that let m be equal to x cubed. Okay, we assume that let m be equal to x cubed, and remember that our m is equal to 3, so 3 is equal to x cubed. So that means our x is equal to the cube root of 3. So this is our real root. This is our real root. Therefore, we have 3 cubed plus 3 squared. This is equal to 27 plus 9, and this is exactly equal to 36. And this proves. Thank you for watching and subscribe to our channel.